Hi all and welcome to my channel again. So today we are going to talk about the data structures. In the data structure we are going to go through our first concept, uh, which is basically the linked list, and we'll start with a you know a way where we look into how the linked list is implemented, and uh, why it is used, what are the advantages of the data structures, right? So this is our first concept. I think before that we have gone through the lists in Python, right? But today we will be going through the linked list, right? So data structures, before that we should go through the data structures, right? And then one by one we'll try to cover as many concepts in the data structures that we can. We have already covered a lot of data structures in the middle, I remember now, which are basically the sorting mechanisms that we did in the past, right? Whether it is bubble sort, merge sort, insertion sort, and different kinds of sort that we implemented. Now, okay, talking about data structure. So basically, data structure is a way of organizing and storing the data in the computer so that we can access, modify, search, insert, and delete that data efficiently. Uh, a simple way to explain it would be that the data structures will be how we organize it, uh, and how we access and manipulate the data, right? So how we have organized it, for example, we have uh, 5 elements, or I would say 5 integers: 10, 20, 30, 40, 50. So the same data can be organized in a different way depending on what we want to do, right? So in an array list, it is organized side by side as a part of a list, a single list, or it could be multiple lists in a stack. So in array, it will be treated like a 0th element, then the first, then second, then third, then fourth, and it is all the way same, like whether you see it in Python or you see it in C++, it's the same way it is implemented. uh, you have to push the stack, you have to pop the stack. We might be dealing with it in the future or the upcoming videos. Then queue, it's the way where we organize the data. It is also one of the structures. And then the linked list, which is our concept, which will be our concept of explanation today, right? And then we finally go to the tree, right? So the data is similar, but the organization of the data is same, like the tree and the branches, right? And the organization determines how efficiently we can perform the operations. Now, in terms of the linked list, when we talk about the linked list, it is one of the most fundamental data structures uh, that we are going to learn today. It's a linear data structure consisting of nodes, where each node stores the data and a reference or pointer to the next node, right? Uh, yeah, in the sequence, right? So it will be a sequence, and the node, it will store the data, and it will also store the reference to the next node inside the sequence. So you can see that the data if a node is storing the data, it is also storing the reference to the next node, which is 20, right? So the key message over here is that the linked list concept is exactly the same in Python and C++. What changes and how the language handles the connection between the two is something that between the two nodes is something that depends upon the coding syntaxes for both Python and C++. And we are going to see today for the Python, but I'll give you a similar gist for the C++ as well, okay, in the final. Okay, so for today's video we will keep it simple. The introduction we have gone through. Now we are going to create the code, and we are going to talk about it now, right? Okay, so let's create a linked list. We'll create a linked list in Python. Let me enter out. Just give me a moment. Okay, so here we go. So first we are going to do is create a class. Okay, so basically a node represents one element of the linked list, and then we create now a class node. We go to the constructor, and this function would run automatically, when we create a node. Okay, and now we'll do a default constructor, that is init self data. Sorry, my bad. Okay, and this is going to store the actual data inside the node. So self dot data is equal to data, right? Okay, and then we are going to take a next variable inside, uh, where we are going to reference the next node, right? So this is one variable which we talked about at the top. If you would see diagrammatically, in one we are storing the variable, in the other one we are going to store uh, the address, or you can say the reference to the next variable, right? uh, Now after this, store the reference to the next node, and initially there is no next node. Okay, right? And we'll do self dot next is equal to none. Now what we are going to do is we are going to create three nodes line by line, right? uh, so that we are going to do as create first node, and that will be node 1 is equal to, let's take the class node, which is the class is node, and then we pass the first variable. Then we have node 2, that is equal to node 20, and then finally we take another node 3, and which we call is equal to node 30, right? So these are the three nodes, and in the node 1 dot next we have node 2, and in node 2 dot next we have node 3, right? So that is how we have created. The third node is the last node, so its next is already null, right? uh, the third node will be the last node, so its next will be none. Then let's make a variable head, which points to the first node. okay, and then head is equal to first node, that is node 1, okay, and then we have to start the traversal, right? So from the node 1, right? So start traversal from the node 1, so current is equal to head. So we take another variable, current is equal to head. So basically the current will take head, and head is having the node 1, so we are basically starting the traversal from the node 1, right? Now we keep moving until we reach the end of the linked list, right? Okay, so we will do while current is not none. So basically what we are saying is that the loop will keep on going while the current is not equal to none, right? So current is getting the value, right? So we are going to print the data over here. The none is incorrect, I have to put it like this, right? And we have to print the data of the current, and then let's print the reference to the next node. Sorry. So what we are going then we are going to move to the next node, right? So what we are going to do is we are going to do print current dot data. We are going to print current dot next, and then in the current value we are going to move to the next node, right? So move to the next node, and to do that we are going to do current equals to current dot next, right? So now when we do that, we are going to get two values. We are going to get the current dot data, we are going to get current dot next, and when the while loop is over, then we go to the node 2, then we go to the node 3 till the time when the current becomes none, right? So when the value is, the while loop will only move while it is not none. Once it is none, it will break the while loop, right? So let's execute it. Sorry, let me check, there is a minor issue. Okay, current dot next line 148 is equal to current dot next. Just give me a moment. I think I have made a mistake somewhere. Line number 75 I have to go. Uh, 75 is what? 75 is class node. Okay, let me check. Okay, my bad. Sorry, I missed out completely on this. Kill self is also a bit incorrect. Cut that out. I think this is okay. Node 10, node 20, node 30, that is right. We go to node 1 dot next. That is node 2, and node 2 dot next will be the node 3, and the third node will be the last node, so that is, so its next will be none. So we'll make a variable head. So basically head is equal to node 1, and then we start the traversal from node 1, that is current is equal to head, keep moving until we reach the end of the linked list. Here is the linked list. Let's execute it now. Let's see. Okay, we are still getting the error. uh, okay, node is not defined. Saying that the node is not defined. Node dot next node 1 is equal to node 10. Okay, it is a reported undefined variable. Let me check it. Okay, class node. Let me go to the top and check. Okay, sorry, my bad. I think I put it. Indentation is incorrect. It should not be inside the class. My bad. Okay, my bad. This was an indentation error actually. So I'm correcting the indentation. Just give me a moment. I actually put it inside the class. It should be outside the class. Okay, let me do one thing. Let me copy this and control that this way. Okay, some of them are okay, but some of them need to be fixed. Okay, so I think now we are good. Let me save this and run it again. Yeah. So now we have got our answer correctly, right? So you can see that currently we are trying to print the data of the current node. So it has been able to successfully print the current node to 10, 20 and 30. And you can see the current dot next, right? So while we put that, it is basically referencing towards the next node, which is basically the address of reference point of 20. On the 20 it is referring to 30, and on the 30 it was already none, so it is reference to none, right? uh, so uh, apart from this, I think we were able to successfully explain the data structure. Oh yeah, I was forgetting about the linked list in CPP. Yeah, so this is the way the same thing has been implemented in CPP, right? So you are basically required to input output operations, right? So IO string, then after that you are going to use the preprocessor director that is using namespace std for standard input output. They create a class, so only the syntax over here is different, the everything else is basically the same. Then you so we basically use the variable to store the actual data. The pointer will store the address of the next node. It runs automatically when, so we have created a constructor just like we created in Python, right? And we store the value inside the node, and then the reference to the next pointer. So currently the pointer will be pointing to none, right? Then we write down the main function, where we create 3 new nodes: node 10, node 20, node 30. Then in node 1's next, like we did in Python, it is node 2. In the node 2's next, we have node 3, and in the node 3's last node, it is already null pointer, right? So now we take again the concept of head. Head is equal to node 1 and current is pointing towards the head. Then the same while loop, and in the while loop we are printing the data, right? So if we give the output over here, so this is exactly what we have written in Python, and this is the exactly same thing that you are using seeing in CPP, but only the difference is over here, right? So let us debug it first. So I'll debug it. Let it run. It is currently in the debugging mode. So on the one hand, you can see we already run the Python one and we debugged it. On the second one, we have run the CPP one and we have debugged it, right? You can see that it's already giving the output, right? So now if I run it again and I run it the compiler that we have for C++, you can see that it is giving the output for 10, 20 and 30, right? If I print the way, so let's say there is one separate thing we did over here, right? Instead of doing this, we also printed out the current.next, which was the reference to the next node, right? So you can do current and pointer to next, and then you can do endl over here. Yes, and then you can print it out. Okay, so first let's debug it. Right, now you can see that the 10, and then basically the first node was printed, and then the reference to the next node, which is 20, then 20 was printed, and then reference to the next node, which is 30, then 30 was printed, and then the last which is basically 0, the reference, because it's not pointing to anywhere, right? So today we understood the basic concept of the linked list and implementation of our first linked list in Python. We created a node, stored data inside it, we connected each node using the next reference, and then we used a head to point to the first node. Linked list from the beginning and the end until we reached the none, right? And this is just the foundation. In the next video we'll go one step further and we learn how to insert and delete nodes dynamically from the linked list. So that's it for today. I would request you to keep practicing both CPP and Python, which is your C++ and Python, and only the syntax is different, but it is very fascinating to learn that and get the correspondingly at the outputs, and uh, I hope you would have enjoyed it, right? And I would motivate you guys to keep the spirit alive and keep coding, and I would see you into the next video, right? Thank you so much.